So the first thing you need to know about significant digits is, when does this apply in calculations? Well, this applies when we're talking about how to round. You never do rounding to the correct number of significant digits until you're on the final step of the problem. You make sure to keep all the digits provided and write them down during every multi-step problem, and once you've done all your calculations, you then do an additional step to state what the final answer is with the correct number of significant digits. Now, how do we know what that number is? Well, there's a couple of rules. Number one, all non-zero digits, so 1 to 9, they're always significant. So in this particular case, we can count 3 numbers. In this particular case, we can count 5 numbers. The decimal point doesn't matter. What matters is that we've got a series of numbers that are between 1 and 9. The next rule to keep in mind is that if you've got a 0 between two non-zero numbers, therefore the 0 becomes significant. So in this case, we count 3 digits, 3 digits. Now, numbers that are trailing after a significant number are also considered significant. So in this particular case here, this 5, this is significant, therefore everything that comes after it is also significant. So there's 3 digits in this question. Same thing with this question. There's the 3, the 0, the 4, 0. There's 4 digits. This can get a little confusing, which is why we use scientific notation. Scientific notation, if we write it in a specific way, we always know it's accurate. So in this particular case, this number here has 3 digits, or this number here has 4 digits. So when are zeros not significant? Zeros between a decimal point and the first non-zero number, so 1 to 9, they're not significant. So in this particular case, this number here is significant due to the 5, the 0, and the 0. That's why it's a 3-digit number. Between this decimal point and the 5, all these zeros here are just considered space holders. They're non-significant. Same thing, this 0 right here is not significant because it's between the 3 and the decimal point. The next one is if you got zeros to the left of the decimal point. These are always considered not significant. So you get 3 digits and 4 digits. This is where it can get a little confusing. What is this supposed to be? So if we look at the number 200, in this particular case, what is it? Well, this is considered to have 1 digit. It's not clear that these zeros should be important. Now, in this particular case where we got it after the 0, we've included these potentially after the decimal, so we're going to assume that with this number, it's supposed to have 3 digits. With this 25,000, this is considered to have 2 digits. So the thing is, though, maybe this is actually 1 digit or 2 digits or 3 digits. It is entirely possible that 200 really does have 2 or 3 significant figures. So we can't write it as simply 200. This is what we use scientific notation for. So in all these cases, we're describing 200. But what this is doing is it's giving us the exact amount of significant digits. So 2 times 10 to the 2 is 200, but this is writing it as 1 digit very clearly. 2.0 times 10 to the 2 is writing it specifically as 2 digits. 2.00 is specifically writing it as 3 digits. So how do we handle that in terms of our textbook? We're going to have to make the assumption that every number in the textbook is considered significant. So if we look at this example of a question right here, they've written 1.64 moles. That's easy enough to say it's 3 significant digits. But what do we do about 800 kelvins? Is that 1 digit or 3 digits? Unfortunately, for textbook questions, we're going to make the assumption that it is 3 digits. We also need to keep in mind that if we've got whole numbers and you've got zeros in front, these are not considered significant. So yeah, again, 3 digits, 3 digits. The last thing we need to talk about is exact numbers. Exact numbers, where you have like a count of something, have an infinite number of significant digits. So if we look at the example of saying that there's 42 people in the room, that's not 2 significant digits, that's an infinite amount of significant digits. So if we have a number that's an exact number, it doesn't affect the accuracy of the calculations. So if we have, for example, an answer here where we say 8 people drink 100 milliliters of water, how much water is consumed in total? Our answer is going to have 3 significant digits, so 800 milliliters. It's not going to be 8 times 10 to the 2. It could be 8.00 times 10 to the 2, but whatever it is, our answer has to have 3 significant digits. This 8 people is infinite. This one is defined as has 3 digits.